Here we go with 12.3. It's the unit circle. So our objective is that students will be able to find the equation of a circle, which we did, and a simple review from geometry. So the basic of trig is a tool called a unit circle, which is utmost important. When you scroll down on the website, it says the unit circle song. Click on that link. It's like a trick to remember the unit circle. This is a simple circle that has a center that's located in the origin, and the radius is equal to 1 unit, hence the name unit circle. So first thing, from your work with equations of circles, which of the following would represent the equation of a circle? So remember, equation of a circle, what do we know? With a center at the origin. Okay, so the origin is 0, 0, remember? And then the radius is 1. So this is actually, remember, minus, what is it? H and, plus, this was our formula back in geometry, plus y minus k square equals to r squared. I know the h and k is 0, 0, and my r is 1, so 1 squared is 1. So this becomes my equation of a circle. That's a simple one. Now 2 says, consider a right triangle here whose hypotenuse is equal to 1 and whose angles are 45. This is an isosceles right triangle since 2 sides are labeled as x. Solve for x. So we know this equation of a circle. We have, one second, here you go, computer froze for a second. So it says solve for x and place it in simplest radical form. So the equation of a circle, remember what we said, it's x squared plus x squared equals 1. So remember, this is my r, the distance, my h and k are actually x comma x. That's my h and k. Now if I go ahead and solve this out, this becomes 2x squared is equal to 1, x squared is equal to 1/2, which means that x is equal to the square root of 1 over the square root of 2. Now this can be simplified as 1 over radical 2, but we know we cannot rationalize the denominator like this, so we have to multiply both of these by radical 2, which will give me radical 2 over 2. And that's the length of one side. Now, the problem is that we need to remember here in example 3, it says consider a 30-60 triangle whose hypotenuse is equal to 1. Clearly, this triangle is half of an equilateral triangle. What is the length of the shorter side? So, the shorter side, what is the length of the shorter side of the right triangle? The side of the triangle is this piece right here. Since it's a right, I can use SOHCAHTOA. This is your opposite over hypotenuse. I can do sine of 30 is equal to x, let's call this x, over hypotenuse, which gives me 1 sine of 30 is equal to x. Sine of 30 is a half, so the shortest side of this right triangle is actually 1/2. Now it says use Pythagoras theorem to find the length of the longest side in simplest radical form. So I know that this is equal to 1/2. Now let's call this, I don't know, a. Pythagoras theorem says it has to be a squared plus b squared equals c squared. So this is a squared, which I don't know what a is, but I do know what b is. In this case, b is half. Oh, I put an equal sign. It should be a plus. And I have half square is equal to 1 square. Now if I go ahead and solve this, I will get a, oh I forgot the square, is equal to 1 minus 1 over 4. So again, I just simplify. 1/2 square is 1 over 4. 1 square is 1. This gives me 8 square is equal to 3 over 4. So a would be the square root of 3 over 4, which is the same thing as 3 over 4 over radical 4. And I know the square root of 4 is 2, and this becomes 3. So the longest side, or my a, is radical 3 over 2. Okay, this is just simple review from Pythagorean theorem. Now let's get into what it should look like, this craziness over here. This is what a unit circle looked like. So based on your work from 2 and 3, we got to fill in the order pairs. So these, as you can see, I already wrote the degrees form. So it goes 30, 45, 60, 90, which is the triangle that we just talked about. Look at the video, the song video. It's actually going to explain this in a lot more depth. So the trick to remember this, we said when it was dealing with these, looking at exercise 2 and 3, we had a little trick to it. So the first thing we have to do is it's going to be a coordinate pair. Each of these going to have a coordinate pair. All of them will be over 2, and that's part of your trick. All of them will be over 2. Now the top kind of goes like this. It goes 1, 2, 3, and then goes 1, 2, 3. The last thing you need to do is put the radical on the top. And the square root of 1 is 1. Just put the radical on the top. So this is actually, the coordinate pair for 60 is actually 1/2, comma, radical 32, radical 3 over 2. This side is actually just the reverse. So for 120, the x becomes negative. So it'll be negative 1/2 radical 3 over 2. For 135 will be negative radical 2 over 2, radical 2 over 2. For this one, take a guess, radical 3 over 2 and positive 1/2. Now at 0, we know it's 1 comma 0 because that's my unit circle. I know that at 270, it is 0 comma negative 1, and on this side it's at negative 1 comma 0. Now for these here going down, it's same exact thing. I'm starting the first, oopsie, it's all over 2, all of these, and we're going to do the same thing, but I'm going to go in reverse order. So I'm going to start with 3, 2, 1, 3, 2, 1. And then what am I going to do? I'm still going to keep my radical sign. Radical on the 3, radical on the 2. Radical on the 3, radical on the 2. And because I'm in the bottom, here my y values are negative. And on this side, we're doing the same exact thing, but now both of them are negative. Because remember, on a coordinate grid, this is negative x, that's negative y. So this 210 is actually negative 3 over 2 comma negative 1/2. This will be negative root 2 over 2, negative 2 over 2. Negative 1/2, negative root 3 over 3. And this is the whole concept of what it is. Yes, you need to know this for the regions. You take a look at that song. It's very, 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 very helpful. Now, why do we need this? Because this is how it comes on the regions. It says, an angle, for each of the following angle, draw in standard position. Give the coordinate pair of a unit circle. So it says an angle that is negative 130. 120. Negative 120 degrees is the same thing as what? So you have to think about it. Negative means I'm going to go clockwise. Perfect. So it's going to come down all the way here. Negative, this is 90, 20. So I'm going to end up somewhere here. This is what's called a coterminal. So the coterminal here is actually 240 degrees. And if I look at my unit circle, it's actually negative 1/2, negative 3/2. So what about 485? I know full rotation is 360. 360, I keep going. 360, I go up. 30 more is 360, and 60 is 390. Keep it going, keep it going, keep it going. 125. So for this, all you got to do is think about 495, take away 360, which is actually 135. So your coterminal is 135, and then at 135 it is negative radical 2/2, comma radical 2/2. Here we go. Pi over 3 is equivalent to what? So how do I change this into degrees? So it's pi over 3 times 180 over pi, which will give me 180 pi over 3 pi, which is actually 60. And then go back to your chart, which you need to know. 60 is actually 1/2 radical 3/2. 1/2 radical 3/2. And the last one is converting it. 3 pi over 2 times 180 over pi. What do you get? This will actually work out to 270 degrees. 270 degrees is actually right on the dot here, which is 0, negative 1. So the basis of this unit is to look at this unit circle. And first thing I would do is write our degree. 30, 45, 60, 90, 120, 35, you know, and keep going. And then remember the little trick. Please take a look at that song and the trick that better explain this, because you'll definitely need to know this. Alright, that's it for today. Go ahead and practice using and knowing what this unit circle means. Good luck!